So, James, recently I had a chance to pay a visit to one of Northamptonshire's greatest undiscovered tourist attractions.
I'm intrigued, Martin. Was it the famous lift testing tower, which is a genuine, real thing in Northampton? That feels like it'd be the sort of on-brand thing we do on this podcast.
Yeah, I'm not sure I'd want to go on that ride, but it definitely sounds fascinating. But no, even better, I went to a village called Chipping Warden to visit some of the construction sites for HS2, fan favorite for listeners of the podcast. And so specifically, this was a visit to see some of the new green tunnels being built at Great Worth and Chipping Warden. And I can guess what your first question is going to be, James.
I was going to say, I've got so many questions. Number one, what is a chipping warden?
So I'm glad you asked. So Chipping Warden, it's a tiny village between Banbury and Daventry, which are two of those sorts of places in the middle of England that nobody quite knows where they are, except they're in the middle of England somewhere. They're actually near where the Battle of Edgecote took place during the War of the Roses, if you're into your history podcasts. It's home to about 500 people, mostly Tories, I suspect. And it's now the site of a massive HS2 field office, I guess you'd call it. So there's this enormous temporary structure, these sorts of Godzilla-sized porter cabins, a massive car park with hundreds of vehicles in it. All of this is about the same size or even bigger than the village itself. And it's quite easy to find. It turns out it's very easy to find HS2 sites when you're going onto Google Maps, because you can literally just go onto the satellite view and you can see this like brown line going up the country where we're kind of carving the earthworks across the land. It's pretty impressive.
That's what sort of amazes me about HS2, Martin, and that you sometimes forget the scale. I think you hear about all of these individual developments, the new bridge, the new tunnel, the new thing they're having to build, but they're having to do this literally all the way to Birmingham with no gaps in one long row. So there is just like an enormous, unfathomably large building site. So I guess my big question though, Martin, is from what you've said. You said this was a green tunnel. How is that different from a normal tunnel? And I mean, other than the fact that we're talking about it because you've got to go and see it, which is incredibly cool, why should people listening who didn't get to see it, including me, care about this?
Okay, so let me try and put this in some context for you. Now, first of all, James, it turns out, and I don't know if you knew this, but HS2 is incredibly expensive. Were you aware of that, James?
Yeah, I think we've probably mentioned it on the podcast at least once or twice.
Yep. So one of the biggest reasons for that is that basically during the original consultation process, everybody insisted that the bits of railway near them should be built in tunnels. So the consultation period, it's a bit like Oprah Winfrey handing out cards. You get a tunnel and you get a tunnel and you get a tunnel for like every local politician, an MP, and pretty much every constituency between London and Birmingham gets its own tunnel. And that's obviously pushed the cost of the project up enormously compared to more grown-up countries that would just whack a nice viaduct across the land and be done with it, basically.
Yeah, this was something we talked about a few weeks ago with Sally Gimson, who wrote a book about HS2 and the politics behind it and so on. And she basically catalogues in her book the great buying off that happened when every sort of, I think every Tory cabinet minister marched into David Cameron's office and said, I want a tunnel. But Martin, you still haven't answered the question. What is the deal? What is the difference between a green tunnel and a normal tunnel?
So when you think about railway tunnels, you're probably thinking about things like Crossrail or the Channel Tunnel, where you've got these big tunnel boring machines deep underground that are carving through the earth like kind of industrial moles. But green tunnels are very, very different. They're built using more of a cut and cover kind of technique. So you carve out a cutting in the landscape, you plop the railway into that, but then you cover the whole thing over again with earth and eventually fields, and that's where the whole green part comes from.
So I guess it's a bit like the original tube lines in London where, you know, even though it was going to be an underground train, they built it by literally digging up the roads and burying a train in there before putting the road back on top again.
Right, and so this is what made the trip quite fascinating and quite informative, because when you hear cut and cover, it sounds pretty simple, right? But actually it's not. It's a massively complicated thing to do, and it really has kind of pushed the limits of engineering knowledge, and not just the engineering, but the logistics involved. And once you understand these things, it really begins to transform your understanding of why HS2 is so expensive and why even small delays like the ones happening due to Dobbin Lane that we've talked about previously can lead to catastrophic increases in costs and delays and so on.
So it's not just digging a trench in the ground and then covering it up with grass and sprinkling some more new grass seed on top and job done.
So in a way, yes, but what you've said is much, much harder than you imagine, right? So let's start with just the earthworks. HS2 is effectively a massive earthworks project, one of the biggest that's ever been attempted. There's more earthworks than there is actual construction or building of anything. So just in this part of the line, which is the 25 kilometers or so between Great Worth and Southam, they're moving something around 13 million cubic meters of earth. The groundwater from all of this work alone, dealing with all of that, requires 55 kilometers of drainage channels to deal with all of that water. And they've built whole like ponds and artificial lakes where they're storing that water to reuse it later on in other parts of the project. They have these incredible 90-ton excavators that can fill a 45-ton truck in literally 3 scoops. So in order to stop them from slowing down, they have 183 of those 45-ton trucks going constantly back and forth like a giant conveyor belt. Just on this stretch, it's like one of the biggest concentrations of construction vehicles anywhere in the world. I think for Caterpillar, it's like literally the highest concentration of Caterpillar trucks that exists on the planet.
Oh my God. Like you associate things of that scale with like stuff in China, but this is just happening in the middle of rural England in that mystery zone between like Birmingham and Leicester and Northampton or something.
The flyover shires,
Yeah.
I guess.
So where's all the earth going, Martin? What are they doing when they're digging it all out of the ground? They've got to put it somewhere, I guess.
So if they took it off site, it would be astronomically expensive. So as far as possible, they want to keep it where it is. And one of the fascinating things about HS2 is that the whole like gradient and level of the route is designed to be as earth neutral as possible. So, we've heard about things like carbon neutral, but being earth neutral, what they're trying to do is take earth from one place and reuse it nearby as far as possible so that they don't have to like cart it off and dispose of it, which would cost millions and millions and millions of pounds.
That sounds better than my idea, which would be to cart it to East Anglia and finally give Norwich a mountain.
Well, I was thinking Boris Island as well, which would be the other perfect location for it. Just ship it up the Thames, job done. But yeah, so they're obviously not going to take all of this off site, so they can build embankments and things and kind of reuse that earth. But still, moving it is incredibly hard. They're driving around this vast construction site that basically extends from London to Birmingham, but is weirdly narrow. So as you're kind of walking around, there's literally cows in fields, like looking down at you in this big like trench that's being built through the earth. And even driving on this in these big trucks is an incredibly skilled thing. The drivers have to learn by basically driving the route for a week to understand every sort of bump and divot and part of it. And they're making hundreds and hundreds of trips every single day. It's an astonishing amount of just moving earth around.
Let's not bury the lead, Martin. Did you get to go on a digger?
Sadly not. I got to watch a crane, but they wouldn't let me go on the diggers. It was raining when I went, and the diggers can't do anything in the rain.
One day, Martin, when we have our big corporate away day for Abundance Media, we're going to go to Diggerland and we're going to drive diggers.
Oh, that's a promise, James. I'm looking forward to that day. But it's also not just fun and doing donuts in diggers. It's pretty serious business, and it's incredibly optimized to a level that's quite staggering. So the thing, and I'm going to come on now because I think what I really want to get to in this segment is there are a whole bunch of things that people don't understand about HS2, and once you realize them, it puts a lot of the other stuff into perspective. So one of these things is that the big costs are fixed and monthly. So you're employing crews and you're renting machinery and land and nearby barns. And that's a fixed cost that's just racking up day after day, week after week, months after months. And so you're always trying to be more efficient wherever possible. You're doing 500 trips a day with these trucks. So even if you're saving like a minute per trip, that adds up very, very quickly. And so there always has to be a truck to meet the excavator when it does a scoop. You can't have it sitting idle for any amount of time. And this extends to things like they actually got human beings to stand at all of the junctions on these dirt tracks because drivers were slowing down instinctively when they came to the junction in case something was coming across it. And so having people there standing and signaling to the driver that it was okay would just stop them taking their foot off the accelerator and keep them at a constant speed. And even that saves millions of pounds.
That's fascinating, Martin. There's a big construction site near me, and there's always just a guy standing there out front, seemingly doing nothing. But I guess, yeah, he must be doing something which is more valuable than all the added costs you mentioned. So this sounds like it would be a really tough job at the best of times, let alone in bad weather, because Britain famously, we get quite a lot of rain, which I imagine must change things.
Well, so they don't operate in bad weather. And this is the second thing that I think people don't fully realize, which is that building HS2 is a lot like farming. It's basically seasonal and it's highly weather dependent. So you can't dig when it's wet, you can't do these earthworks, you can't drive trucks on a lot of the tracks because they basically just turn to wet clay. And everything has to happen in sequence. So yeah, you build the foundation of the tunnel after you've leveled the earth, and then you do each part basically in sequence behind that, which means that you've got all of these dependencies. And say an excavator breaks down with a day's worth of excavation to go, and let's say it takes a few days to fix it. Now you're 4 days behind. But if it then rains for the next week, suddenly you're like 2 weeks behind. And if you've now run into the winter, suddenly you're 4 months behind. So even a small delay can just start to rack up and rack up because of the weather or other things that it interacts with.
So, Martin, is there any good news? We've had a really warm summer, or so I'm told. I've been sat under my air conditioning all summer. Is that been good for building?
Yeah, so genuinely, they've made a lot of progress this year and they've actually done better than they expected to do, in large part because it's been an unusually warm, hot, and dry summer. So they're actually ahead of the targets that they set for themselves this year.
Oh,
So it really does help.
So does that mean we could be looking at maybe, 2038 or whatever it is rather than 2039?
I think steady on. I think there's probably still some challenges to come.
Okay, Martin. So, like you say, so with us earthworks, there's so much more complex than you think. But I guess once that's done, and they must have done quite a lot of that now, they've been digging HS2 for a while. But once that's been dug out of the ground, you can just drop in some concrete, put a train inside, job done, cover it over.
So it turns out once again, James, that building HS2 is less simple than we naively expected. And this actually comes nicely onto the third thing that I think people don't understand, which is, again, you talk about a cut and cover green tunnel, right? Now, what you're basically doing is they're casting these concrete structures off-site and they use them to build sections of the tunnel. So they have like a structure for the left wall, a structure for the middle wall, for the right wall, because it's two tunnels going through it, and then two arches that they drop on top and kind of put in place. And that creates a kind of McDonald's logo, effectively, which is a cross section of the tunnel. And they just keep putting those down. And that effectively builds the core structure of the tunnel. But what you're basically doing is building a really long, 3 mile long building. And you can't just pile thousands of tons or tens of thousands of tons of earth on top of a building because you'll basically like collapse it. And so it's not the same as digging a tunnel where you're deep underground and you're going through strong, stable, compacted rock and kind of making a hole through something that's solid. You're effectively building something. And if you get that building even slightly wrong, the whole thing can just collapse. And this actually happened at Gerrard's Cross on the Chiltern Main Line in 2005. They wanted to build, of all things, a Tesco supermarket over the top of a railway. It was kind of like a land reclamation project. They didn't have a suitable area to build on. So they thought, well, why not cover over the railway, put, I guess it's not a green tunnel, more of a grey tunnel, like a big Tesco car park, and a superstore on top of that. And it was a brilliant idea. So they started making the tunnel. They began backfilling the trench with earth while the railway line was actually in operation to try and get this thing going.
I'm amazed this got planning permission, Martin. Where were Britain's NIMBYs when someone was trying to build something? This would have been a perfect excuse to cancel the whole thing.
Well, yeah, I mean, and actually, we could almost do an episode on that supermarket because it was a 7-year saga. John Prescott got involved. This is like from the late 90s that it was first being proposed. And there was a huge protest from locals because they wanted a Marks and Spencer food hall instead of a Tesco. They thought it was apparently a bit beneath them. But
is that real? Is that true? Is that a true thing?
That's genuinely a quote I saw in some of the articles were like, oh, we wish it were a Marks and Spencer. We'd probably back it then. But yeah. But Tesco, come on. Which is a sentiment I can get behind. But I mean, this turned into almost a catastrophe because effectively, if you imagine that sort of arch that you've built out of concrete and you're piling rubble and earth and things on top of it, Imagine if you just press down on the top of an arch, but you're not pressing in from the sides as well. The danger is the whole thing just caves in and the sides kind of push outwards. So you've got to be really, really careful to balance the loads as you're piling the earth back into this trench. And if there's rain or heavy rain, as there was at Gerrard's Cross in 2005, that's all soaking into the soil and changing the weights and the distribution of weights. So, at any rate, at 7:34 p.m. on the 30th of June, just after rush hour, incredibly luckily, a whole long series of these arches just gave way. 100-foot long section of the tunnel collapsed, and something like 15,000 tons of earth piled down onto the train tracks and just completely obliterated it. There was a train approaching from High Wycombe at the time.
Oh my God.
They got a warning from a radio over the radio, luckily, and basically had to put on the emergency brakes. Luckily, we're able to stop and get people off at a golf course, which I think, along with the Marks and Spencer, tells you something about the area that they're operating in. But all joking aside, it was an absolute miracle that nobody was injured. If there had been a train in the tunnel at the time, and again, bear in mind this is like 7:30 in the evening, hundreds of people could have been killed by this.
Holy shit, I've got no memory of this happening. I mean, I would have been around and reading the news at the time. This sounds like it would have been a big deal. Bloody hell.
Well, you would think so, but a very minor incident happened the week later, which was the 7th of July bombings in London.
Ooh.
So I suspect that probably what happened is that it was a fairly big deal, but attention quickly moved on to other things, which is probably a good thing if you're Tesco. But anyway, so the point here is that backfilling is like an entire science in its own right. The consistency of the ground has to be perfect. It has to be porous enough to allow rainwater to drain through it, but compact enough that it's not going to move around or the weights aren't going to change or shift. And if they get even a tiny piece of this wrong, they're constantly using sensors and assessments to test it as they go along. If they find that a bit's wrong, they have to undo a whole section of the tunnel, lift tens of thousands of tons of earth back out again, and refill it. So this is like a science project, effectively. And then the tunnel itself underneath has to be waterproofed with a repairable membrane system, and even that's not a solved problem. They had to build basically a prototype tunnel section nearby to test out different ways of waterproofing it, because obviously if there's a puncture, you need to be able to reliably repair it. And this is all new stuff that we're trying to understand for the first time, effectively.
But this is blowing my mind a bit. It sounds like a research project, but we've had tunnels for years. Do we really need to prototype and test stuff? I mean, surely people have dug tunnels before.
Well, to some extent, it is a research project. And to give you one last example, which kind of gets to your implied question, the speed of trains entering the tunnel is a whole other problem. So when they built high-speed trains in Japan for the first time, they ran them through normal train tunnels. And what they hadn't realized is that if you have a train doing 200 miles an hour and you slam that into a narrow space inside a tunnel, suddenly the air in that tunnel has nowhere to go. So it's effectively like a sonic boom. When a plane is going so fast, the air can't get out of the way fast enough. You're stuck inside this tunnel. The pressure builds to massive levels. There's an enormous blast, and it can actually damage trains because the forces involved in the air pressure are so high. So when you see high-speed trains in Japan with those massive long noses on them, that's nothing to do with going faster or streamlining for going through the air. Or it kind of is, but it's specifically for tunnels. It's to make the interface with the tunnel longer so that the air has more time to be displaced around the front of the train. And that's why the noses on those trains are famously so long.
Oh my God. This is blowing my mind, Martin. I mean, I thought it was also just because they look really cool.
I mean, probably it is also because they look really cool, but I mean, it's that's the official reason, right? So in England, we're not going to have those long noses on the trains. Instead, we're going to have tunnel portals that actually kind of breathe. So the idea is that the walls of the entrances to the tunnels are porous, and as the train hits the end of the tunnel, the air gets pushed through the holes in the walls, and the whole thing kind of breathes out and then back in again. And again, all of this sort of gives you an idea that we're right at the limits of engineering knowledge and understanding. Everything from soil movement to hydrodynamics to air displacement to even the curbs inside the tunnel that are designed to handle what would happen if an HS2 train derailed at 200 miles an hour inside a tunnel. All of this has more in common with the Apollo program than a standard civil engineering projects, right?
As in taking up an enormous percentage of GDP, wildly and costly.
I think the Apollo program was more on budget, so
Yeah.
maybe the extension doesn't quite.
So, Martin, other countries, though, we're not the first country to try and build a high-speed train. It doesn't seem that impossible. Other countries have done it, like you mentioned, Japan. So most of these problems must surely have already been solved.
Well, so yes and no. So certainly they've learned an enormous amount from French engineers and from places like Japan, France, Spain, but there's a fundamental difference in basically the scale and complexity of what we're trying to do. So if chipping Warden were in China or Japan or even Spain or Belgium, none of which I think are options that the residents of chipping Warden would be very pleased by, but that's another matter. But in those cases, you would just build this railway on a viaduct and it would look very nice and it would just go over the tops of the fields and it would be a fraction of the price. And things like green tunnels, where they existed, would be quite small and quite rare. So, we have them in France, but they're not necessarily that long or that frequently used. But in the UK, we're building miles of these things for essentially just political reasons. So we're not doing all of this to solve an engineering problem, even though it's a fun engineering problem to solve. We're solving these engineering problems to get around a political problem. And we're paying tens of billions of pounds extra to do it. I won't say who this was because I might not be allowed back again, but somebody made a joke to me that you could have just made all the villagers in the area millionaires and it would have been cheaper than doing this and probably solved a lot of the local objections. And obviously that was a tongue-in-cheek comment. But mathematically, it's frighteningly close to being accurate.
It's slightly scary, Martin, how many problems can be solved just by, shoveling money at people like that. It reminds me of like your NHS plan a few episodes ago, where basically you said, we'll just pay for everyone to go on Ozempic and it will sort out the obesity problem. And that seems like a much more direct way of solving the problem. So yeah, maybe we should just pay off all these already presumably quite affluent golf club attending people.
Yeah, I mean, there were probably other negative side effects of the systematic use of bribery, but we can deal with those later. But it's effectively what the Bat Tunnel is, right? The famous Bat infrastructure project there, because essentially it's an insurance policy. I forget who originally made the point, but it's not really there to protect bats or to improve bat populations or anything like that. It's largely just to stop them getting sued, and so they've had to throw £100 million at this giant structure in the middle of nowhere. And ultimately, it's these political reasons, it's the insistence on putting absolutely everything in tunnels that are why the costs escalated, and why, for now at least, we're not going further to the north. Politicians made these choices. They were completely oblivious to the consequences, or they didn't really care about the consequences down the line. And so, the knock-on effects of that is it became much harder to do the rest of the projects, and the phases to Leeds and Manchester and so on will probably not happen for many years. And the other big tragedy of this is that, much like the nuclear industry in the 20th century, will have learned all of these engineering lessons, will have done all of this research and science to build this line, will know exactly how to build it better next time, and then we'll just lose all of that knowledge because we won't do it. And if we do come to it again in 20 years' time, we'll have to learn the whole damn thing again.
It's a bit like if you asked me to factor a polynomial equation. I couldn't do that these days, even though I could 20 years ago. Anyway, Martin, I think if people don't want to lose any knowledge, then they should definitely like and subscribe our podcast. If you're watching on YouTube, you can do that now. We're now on YouTube. Like the Abundance Agendas page, subscribe to us there, or just make sure you're subscribed in your podcast app to get our show every week. And retain that special, important knowledge of whatever it is we're talking about. Is that a good enough tenuous link to call people to action, Martin?
I mean, if anything, James, it could be more tenuous, but I think we'll go with it.